thought we would look at a few more problems from the Chapter 3 review. So we are down to question 20. And this one asks us to enter the possible rational zeros. And we'll just abbreviate that, possible rational zeros. So remember, this is plus and minus factors of the constant term over factors of the leading coefficient. Well, your leading coefficient is 1, so it's just going to give us the factors of the constant term. So 24 has a lot. You have to be careful. So 1 goes into 24, 2, 3, 4, not 5, 6, not 7, 8. Let's see, 8 times 3, so 12 would be next, and 24. So plus and minus 1, 2, 3, 4, 6, 8, 12, and 24. So no fractions in there. So we should not get fractions for our zeros. And then they said use synthetic division or other various methods to determine the actual roots. Mrs. H is going to look at a graphing calculator. Roots and zeros are the same thing. So I have actually already typed this in if it kept it after it turned off. So there we go. So put it in your graphing calculator under y equals graph. And so we have some guesses here. X equals -2. And this looks like 3 and 4. We should double check though. So -2, 3, and 4. And the way I'm going to double check is I'm going to do second calc value. So second calc value, choice number 1, and I'm going to enter those, and I should get y equals 0 to go with it, and then it would be an x-intercept. So we'll do it for each one. So second calc value for 3. Yes, it works. And second calc value for 4. Enter. And it also works. So these are my 3 zeros. -2, 3, and 4. And we can look just to make sure. We'll also have a look at problem 23. These are both from section 4.4. And so this time they want us to write a polynomial of nth degree. Our degree is 3. And these are the 2 zeros they've told us. And so we need to get the factors. So for 7 to be a 0, x minus 7 will be a factor. And we're going to have some leading coefficient there. And then we'll have x minus 9i. Whenever you get one complex 0, you get conjugate pairs. So if minus 9i is a 0, plus 9i is also a 0. So this one is really minus the negative, which gives us the plus. If we want to, we could multiply this out. I don't think the computer program likes the i's left in there. So if we want to go ahead and multiply just this part, this will be x squared. You get minus 9xi and plus 9xi, and I reverse those as I said it. So first we have plus 9xi, minus 9xi. They're going to cancel. And then minus 81i squared. I squared gives you -1, which makes this a plus 81. So this piece ends up being x squared plus 81 times x minus 7. And then we'll use our other condition to figure out the a. So they say when you let x be 2, the y is equal to 850. So the 850 will go here. Keep the a, x is 2. And so this gives us a negative 5. 2 squared is 4. 4 plus 81 is 85. So we have negative 425 a equals 850. So divide by negative 425, and a will equal negative 2. So our polynomial is negative 2 times, and we'll use this form. I don't think we have to multiply it out. I think you can enter it just like that, and they will be happy. They would not like, I don't think, the i's lived in it, in the first one. So we will try that. They actually work it out in their answer, but I think you can enter this. Very good. I decided to backtrack and do one more problem. Problem 21 will do, because 4.4 is really about finding all the zeros. So we'll add one more question there. First, they want us to list the possible rational zeros. So we can do that. Remember, it's plus or minus factors of the constant term over factors of the leading coefficient. Your leading coefficient is again 1, so you don't have to write that in the denominator. We'll just do factors of the constant term. So 1, 2, 3, 4 doesn't work. It doesn't go evenly into 18. 5, no. 6, 9, and 18. So those are our choices. Again, on this problem, you don't have fractions, and that's going to be important in this problem. So we can check those. There you go. Too bad you guys don't have a plus and minus button. That would help, but we don't. I would go straight to a calculator to find the rest. I would not try doing those with synthetic division, just guessing until I found one. So go to a calculator. I typed this in already, and let's just look. So I typed it in under y equals, let's say graph, and there's your picture. All right, and so we have to check these. Possibly a negative 5, and maybe a negative 3, and I'm pretty sure that negative 1 is off to the side. So we'll double check here with second calc value. So second calc, choice number 1 value, and we'll try negative 5. And we get back y equals negative 2. So this did not work. It is not a 0. So it's off to the edge a little bit there. Let's test the negative 3. Right, negative 3 is, so we're good there. And let's test negative 1. So second count value. Negative 1 is not either. It's slightly off. But we did get 1, 0 out of there, which is good. We can work with that. So we'll go to synthetic division, and negative 3 is a 0, so we'll divide by negative 3. Pick off your coefficients, so 1, 9, 24, and 18. Skip a row, bring down. So 1 times negative 3 is negative 3. 9 minus 3 is 6. 6 times negative 3 is negative 18. And we'll subtract there. And that gives us 6, positive 6. And 6 times negative 3 is negative 18, which gives us 0. We expected that because we were dividing by one that we had already verified as a 0. What we did that for was to get this quadratic out of it, because we know how to solve a quadratic equation. So we're dropping 1 degree lower. We have x squared plus 6x plus 6, and we're going to set it equal to 0 and solve. Now, because I did not get answers out of there, I'm not going to be able to factor this down. So I'm going to have to go to quadratic formula. There were no more rational possibilities, so nothing that was a fraction. That means the possibilities are irrational. They're not going to be complex this time because we had dots on the line. It wouldn't cross if you had complex zeros. So they should end up being ones with radicals in them. So that would be irrational roots. All right, so we have a equals 1, b equals 6, and c equals 6. And we'll do quadratic formula. So x is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. And then we'll have to clean up. So we have negative 6 plus or minus square root of 36 minus 24 over 2. And so 36 minus 24 is 12 over 2. And we need to simplify that square root of 12. 12 has 4 times 3 in it. And 4 is your perfect square. So we can take out a 2. So 2 times the square root of 3. And we can simplify this because around your plus and minus, you have a common factor of 2. So it can divide out, and this will give us negative 3 plus or minus the square root of 3. So that is 2 of your zeros. They are irrational because you cannot write square root of 3 as a fraction. And then our other 0 was negative 3. So those are our zeros, and there you go. Negative 3 plus the square root of 3, and negative 3 minus square root of 3.